Hello everyone, and welcome back to the Deep Learning for Teens video series. In this video, we'll be converting an ANN into a CNN using just a few lines of code. I highly recommend watching part 5 of this video series, as part 5 is where we made the ANN which we will use in this video. However, this is not absolutely necessary, as you will see shortly. Before we begin, you need to have this Colab notebook open on your computer. If you watched part 5 of this video series, you should have already created this Colab notebook during that video. If you did not watch part 5, I recommend watching it before this one, especially if you are not familiar with Google Colab. Otherwise, you can just go to the link on screen, which is also in the video description. Now, we have to create a copy of this notebook by going up to File and clicking Save a Copy in Drive, and you need a Google account to do this. And once this is loaded, we can start to transform this from an ANN into a CNN. So first, we scroll down to part 4, which is where we create the model, which is currently an ANN model. And so we can click here and press enter once and delete all of these tabs. And now we can start adding a few extra lines to convert this into a CNN. So first, we want to add a convolution layer. And we can do this by typing tf.keras.layers.conv2d, and we want 64 filters in this convolution layer, a kernel size of 3. We are going to use the ReLU activation function, and since we're using MNIST images, our input shape will be 28 pixels by 28 pixels, and these are grayscale images, so we are going to put a 1 for grayscale. And this is our first convolution layer, and we can add a second one by putting a comma. And actually, before we add another convolution layer, we're going to add a pooling layer, and so we can write tf.keras.layers.maxpool2d. And in this pooling layer, we're going to have a pool size of 2, and we're going to have a stride of 2. And notice we put strides instead of just stride. Anyways, we can then put a comma, and we're going to add another convolution layer this time. And so we're once again going to write tf.keras.layers.conv2d, and this convolution layer will have some separate parameters than the first one. In this one, we're going to have 128 filters, a kernel size of 3, and we're still going to use the ReLU activation function. And this is and we only need to add one more line after this, and this will be another pooling layer. And so we can write comma and then enter. And now we're going to add another pooling layer. So tf.keras.layers.maxpool2d, and pool size will be equal to 2, and our strides will also be equal to 2. Put a comma, and we have now finished making our CNN. And so we can go up to the top and start running each of these code cells. So we click this play button, and the first time it's going to connect to a computer for us so we can run all of this. And so now it's running, and it should be finishing fairly soon. And there it's finished. And now we can start running the next code blocks, and if any of these fail, you can go back to previous points in the video and check your code against mine. And so we're going to continue running all of these code blocks. And so now we are compiling the model, creating and compiling it, and we are now going to train the model. And I'll see you once this is done. And so our training has now finished, and as you can see, on our first epoch, we were able to achieve 95.55% accuracy. And remember, our first epoch is where we have gone through one cycle of training. And on our last epoch, we were able to get a validation accuracy of 97.5%. and so we were able to increase in accuracy over time, which is good. In the next video, we'll be converting the CNN we built in this video to use a COVID-19 dataset as opposed to an MNIST dataset. I hope to see you then.